Hi everyone. The topic of our team is constraint optimization. In terms of this topic, one of the most important part is the constraint least square problems. For this project, we focus mainly on the linearly constrained least squares problem, and we will talk about the problem in 3 steps. Firstly, we will give a general introduction of the methods to solve the CLS problem. Then, we will dig into the theoretical details of the functions. Finally, we will present the benefits of the applications in other areas. Now let's start by looking at the two main methods going to be used to solve this problem. Recall that the problem is to minimize the square norm of ax minus b. There are two methods to solve the CLS problems. The first one is via the KKT equation, and the second one is via the QR factorization. Another important special case of CLS is the least norm problem. The objective is to form Lagrangian function and with Lagrange multipliers and to satisfy the optimality conditions. Here section 3.3 gives a general conception of Lagrange multipliers. In the previous section, we have already mentioned there are two main methods to solve CLS problem. Here in this part, we will explain these two in detail. The first method is using KKT equations. The algorithm of solving CLS by KKT has two main steps. The first step is to form Gram matrix. The second step is to solve KKT equations by QR factorization and back substitution. Another way to solve CLS is using QR factorization. The corresponding algorithm is as follows. In addition, when we form the KKT matrix, one potential problem is that the Gram matrix A transpose A can be far less sparse than the matrix A. This problem can be avoided. As what I mentioned before, there is a special case of CLS, which is called least norm problem. The solution of this problem is shown in this section. Finally, we want to make a short introduction of the applications of CLS. There are two main applications for constraint least squares. One is linear quadratic control, and another is linear quadratic state estimation. In the control problem, we can choose the inputs and they are under our control. The theory of optimal control is concerned with operating a dynamic system at minimum cost. The case where the system dynamics are described by a set of linear differential equations, and the cost is described by a quadratic function named the LQ problem. Once we choose the inputs, we know the state sequence. The inputs are typically actions that we take to affect the state trajectory. In the estimation problem, the inputs called process noise in the estimation problem are unknown, and the problem is to guess them. So this is our brief introduction of the constraint least square problems. That's it. Thank you.